You might have observed there has been a recent trend of installing RGB lights in your bedroom and living rooms. But the question is how to install them. So this video will answer all your questions regarding installing RGB LED strips, right from how to choose the right type of LED strip, how to choose the right power supply, and how to connect 2 or more LED strips together. So make sure you watch till the end, and if you haven't subscribed already, please do subscribe and hit the bell icon. It would mean a lot to me. Coming to the very first part, which is how to choose the right type of LED strip. Now there are a lot of types of LED strips available, and they can be categorized based on their color and whether or not they are addressable. Addressable means if each LED can be controlled separately or not. Based on color, we can categorize it into single color, dynamic tunable white, RGB, RGBW and RGBWW. The one that we are going to cover in this video is RGB non-addressable. There are also several types of non-addressable RGB LED strips such as 3528, 5050, 3014 and so on. The numbers represent length and width of the SMD LED chip. The one that I used was 5050 type, which consists of 5mm by 5mm SMD LEDs. However, you can also use any other type. Different LED strips have different densities of LEDs such as 30 LEDs per meter, 60 LEDs per meter and 120 LEDs per meter. Higher density would mean more intensity of light and high power consumed per meter of LED strip. In this case, I use 30 LEDs per meter type. You can also choose between waterproof and non-waterproof type of LED strip. I chose waterproof ones which provide more diffuse light, but since in our application we don't need waterproofing, so you can use any type. So here you can see the LED strip I used, 5050 non-addressable waterproof type, 30 LEDs per meter rated at 12 volts. Now I got 4 strips 2 meters each, which come with a controller, remote and adapter. The adapter is rated at 12 volts 1 ampere, which is only suitable for one strip, but since we will power all the 4 strips together, 1 ampere won't be enough, so we don't need the adapters. And out of the 4 controllers and remotes, we only need one. I used another one that I had with the 44 button remote instead of the default 24 button one, but you can still use the one provided with your LED strip. Next step is to calculate the maximum power consumed by LED strips and choosing the right power supply rating. Now we need to make some very simple calculations to know how much current our system would consume and how much our power supply should be rated at such that it can supply enough power for a long time without malfunctioning. As explained before, I used 30 LEDs per meter type of LED strip, but this explanation stands for all types. An RGB LED actually consists of 3 different color LEDs, red, green and blue, in a single package, and each color would consume 20 mA max. So each RGB LED would consume 60 mA max. Now 12 volt RGB LED strips contain various segments connected in parallel. Each segment contains 3 RGB LEDs in series, which means all 3 together would consume the same current, that is 60 mA. Now if one segment that has 3 LEDs consumes 60 mA max, we can also say each LED consumes 20 mA max. So max current consumed by an RGB strip can be given by a simple formula, which is 20 multiplied by N multiplied by L, where N is the number of LEDs per meter and L is the length of strip in meters. In my case, N is 30 and length of LED strip is 8 meters. So plugging in the values, we get max current rating of 4800 milliamperes or 4.8 amperes. Taking another example where we say number of LEDs per meter is 60 and length of LED strip is 5 meters. So we can get a maximum current rating of 6 amperes. So you just need to remember the simple formula, which is 20 times N times L. Ideally, the power supply current rating should be at least 20% higher than the max current calculated, but any value greater than the calculated value will work. However, the adapter may then not last very long. So I used a 12V 5A adapter. Step 3 is joining all LED strips together if you have 2 or more separate LED strips. There are 2 ways to do so, using a connector or soldering them together. Connectors might not always ensure good connection, so here I am going to show you how you can solder them together. For non-waterproof strips, soldering is pretty easy, but for waterproof type you will first need to cut and remove the silicone coating. So first I desoldered the connector from second LED strip. Then I used a paper cutter to make a small cut just before the copper pads and fold the strip a little. Then use my nails to remove the waterproofing. Then I applied some more solder to the copper pads, and then I repeated the same for the back end of first LED strip. To join them together, I taped both of them on a solid surface like a steel ruler to keep them in place while soldering. Then you just need to apply some more solder to make a connection. Then I tested all the colors to make sure the connection is good. At last, to make a strong and tight connection, I used some epoxy glue and left it to dry overnight. Now in my case I had 4 LED strips, so I repeated the same process 2 more times. After all the strips are joined, I soldered a connector at the other end such that it can be powered from both ends. Now you can connect everything and check if the entire LED strip is working fine. Moving on to step 4, which is connecting the whole setup to AC mains supply. The adapter that I used had a power jack to connect it to AC mains, but since I wanted a more permanent connection rather than plugging it in into a plug point, I desoldered the power jack and soldered 2 wires in its place. Then I used hot glue for secure connection and put everything back in place. Next, you just need to connect adapter wires to AC mains supply. In my case, I didn't have a spare AC supply, so I installed 2 switches, one for my study table lights and one for these mood lights. To summarize the connections, first the adapter which is connected to AC supply gives 12 volt output that goes to the controller, which then controls the LED strip. And as you can see, first switch powers up my study lights and second switch powers up these mood lights. Now coming to the final step, that is installing the LED strips. It is important to wipe the surface that you are going to stick the LED strips on with some rubbing alcohol such that it is free from dust and grease. Most LED strips come with 3M tape at the back, which makes installation pretty easy. You just need to peel off the covering on the adhesive. Rest of the process is pretty straightforward but the most time consuming. It might sound easy but it's actually not. I was almost halfway when the LED strip started falling. The weight of the silicone waterproofing is probably too much for the 3M tape to handle. And this is how all the effort went in vain. It was so frustrating that I almost gave up. So I resumed work the next day, this time using a bit of hot glue at short distances, which took even more time. But this time it was a success. I added some hot glue at the end to keep the strip in place. Then I also put the IR receiver and controller in place. Now that everything is complete, we can go ahead and finally test it. Here comes the moment of truth. And as you can see, they are working just fine. There are a lot of different functions available, like 20 preset colors, fade, jump, blink, etc. In some controllers like in mine, there is also a DIY function which lets you create your own colors. So just go ahead and experiment. In conclusion, these lights ended up looking great and quite relaxing. I will also try to make a controller to access these lights from a smartphone and make them sync to music. If I do, I will surely post a how-to video of that as well. That's it from my side. Thanks for watching and don't forget to like and subscribe. You can also support me for my future projects via PayPal.